So in C#, we also have the concept of variables and data types. So what a variable is a space within your computer's memory system that holds particular values. And basically, variables are important because it allows us to avoid code repetition and redefining code over and over again. So I'll give you an example, but the very first thing we're going to do is we're going to come back up here to our main method, and we're going to define another method called variable or variables and data types with a semicolon. Now, as you can see, I'm getting an error message because this does not exist. So what I'm just going to do is I'm just going to copy this for brevity, copy this method called name. I'm going to come below the closing bracket of the print to console line, and I'm going to define a new function called static void and then variables and data types and hit enter. So now we have our new method here. Now in this method, we're going to be doing several things. In this method, we're going to demonstrate how variables work and exactly what you need to know with working with data types. So the very first thing I'm going to show you is data types. So in C#, every single object or every single value you'll deal with will have some sort of data type attached to it. Either it will be a built-in data types like integer, like string, like character, Boolean, which is a true or false value, or it could be a data type that you define yourself. So let's start with the very primitive or basic data types first that are coming together with the .NET framework. So the very first thing we have here is an integer, which is a number, is a whole number. So if you think of 0, 5, 10, 100, 1000, these are integers, and an integer can be signed or unsigned. So in this case, we are going to define just a basic integer, and we'll just call this integer age because we want to define the age of a person. So int age, let's say int age is 30. So this is basically assigning the value of 30 to the variable age, which is a number or an int, the int data type. And let's just make sure that this is working. So we're going to console.writeLine age. Okay, and we're going to save that, and then we're going to do our shortcut key, and we'll run this. And as you can see below, right below the output of hello world, we see 30. So that's working. That's great. So let's cover some other data types in C#. So the next data type we'll cover is called float. And the float basically is a decimal point number or just a decimal number. And there are actually different types of decimal data types in C#. But float is the one we'll cover first. So let's define, let's say, a temperature. So we'll say float temperature, and that will be equal to, let's say, 20.4. Now, as you see, as I close this statement out, I'm getting an error message. And the reason why that's happening is because we did not define F at the very end. So I'm just going to put a letter F at the end. And what that tells your computer in .NET is that this number should be treated as a single precision floating point number. What that means is that we're not really so particular, or so, we don't really care very much about how accurate the decimal points are, the decimal values are behind or to the right of the decimal point. We just want to have a floating point number that is single precision to the single digit after the decimal point. And generally, the reason why we might want to do that instead of getting more precise with our value is because floats typically run faster than other data types. So if you don't really care much about how precise the number is, you could just simply use a float in most cases. In the case of defining a temperature, I don't think it's a big deal if we just use a single point or a single precision value. So let's output this temperature. So we're going to say console.writeLine, as we have been doing, and we're going to just output temperature. And we'll close that off, and let's run this, and let's see what we get. All right, so as you can see below, we get 20.4, and so it looks like that's working. Okay, so if we want to get a little bit more precise with our decimal value, instead of using a float data type, we can actually use one called double. And double data type gives us double precision or double digit precision, which essentially means it's a little bit more accurate when dealing with longer decimal numbers than float is. So let's say we want to define the interest rate of a loan. Let's create a variable called interest. So we'll say double interest, and we'll set that to 5 0.53 and close that out. Now, if you notice, I'm getting no error message this time. And the reason why is .NET already understands that this is a standard floating point number. So there's no need to be alarmed there. So I'm just going to simply output this. So I'm going to do console.writeLine. I'm going to show you guys something new. So we don't just need to always output the variables. What we can actually do is we can prepend a string or even append, depending on what you're trying to do, a string to the argument value of this WriteLine method. So if I want to display additional text, for example, before the actual value, I can prepend a string. So let's call this interest. And I'm just going to throw in there a plus sign and then the variable interest. So if I save that and I rerun it, we'll see that we have interest 5.53. So that's working as expected. That's great. All right, so now let's say we want to go even finer than that. We want to fine tune this decimal value as much as possible. So if you ever work in a bank in the future as a .NET developer, you may want to use this particular data type because it's going to be the most accurate precision that you can get from any decimal number. So a great use case for this is working at an investment bank, for example, or any bank where you need to be fine-tuned to the decimal point. And the name of this data type is actually called decimal. So let's define a decimal value. Let's say stock price. We want to define the price of the current price of a stock. So I'm going to write this out as stock price. And notice that this variable, I'm actually writing this in camel case. So again, just to kind of reiterate and just to clarify an earlier point that I made, C# functions are written in Pascal case and variables are written in camel case. So basically camel case is when the first letter of the variable name is in lowercase and then any following word, the very first letter of that following word is written in a capitalized case. Whereas with Pascal case, the functions are all written in capital letters when it's the very first letter of a word. So in this case, I'm using camel case to define this variable, stock price. And I'm going to set this stock price to, let's say, 4. And we just throw in a bunch of numbers here and close this off. Now, if you guys notice, I'm still getting an error message here. There's a squiggly line here under the value. And that's because just like the float number, I have to specify to .NET that this value is a particular or special floating point number. So to do that for decimal, I would specify a capital M. And the way to remember this is for decimals, M stands for, let's say, money. Okay, just for you guys to remember that as a mnemonic device. So now I'm going to output this and see what we get. So console.writeLine, sorry, something happened there, console.writeLine. And let's say we're going to output the stock price. Stock price. All right, let's see what we get. So if I save that and I run, so we're getting our first error message here. Console does not contain a definition for write. So I'm misspelling something here. Okay, let's fix that. I know what it is. So WriteLine, that should work. So if I run this, now you'll see that I'm outputting the stock price to the T. So it's a very precise decimal value. Now you may be asking, well, why would I use float or double when I can just use decimal? There are some performance differences, especially when you're dealing with larger applications between the three. So I would definitely suggest that you use float or double when you don't really care about having the very precise value. Whereas I would use decimal if I'm working with money. That's the best way to think of it. Money or anything else that's very sensitive to any decimal being off by, a tenth, a hundredth, a thousandth, and so on. So that's the best way to remember it. All right, so let's move a little bit away from numbers for now, and let's move on to other data types in C#. So let's say if we want to define a character. So a character can be any, if you look at your keyboard, you see basically various types of letters and numbers and, even special characters. So in C#, we can actually assign one of these as a value to a variable by specifying the char keyword. And the char keyword basically signifies that any value stored in this variable will just be a single character. So I guess we can assign a letter grade as if we're back in school. So we'll say char grade, and let's just say that we were good students, so you got an A. So as you see here, we define just a single character, so I can output this, and I'm just going to do a simple output here of console.writeLine, and let's just say grade. So let's run this in our console. Let's see what we get, and as you can see, we're good students because we got the letter A. That's great. And something to keep in mind, when you define a char or a character, notice the difference between that and a string. In the case up here, we define a string with double quotes, whereas a char is defined with a single quote or a set of single quotes. So that's something to keep in mind. Remember, if you use double quotes instead of the single, you're actually defining a string, which is actually the next data type I'd like to cover. Now, this is a very common one you'll be using across many applications. So to define a string of text, we just specified the string data type. So let's define a name. So let's say string name is equal to Ron, which is my name. And we close that off, and notice that we have these double quotes, as I said before. Now, when you use a string, you can actually define a string that just has a single character within it, but .NET will not recognize that as a character. It would actually recognize that as a string. So keep that in mind. So I'm going to just set that back to Ron, and I'm going to output something interesting here. So console.writeLine. And what I'm going to do is I'm going to introduce myself. So to do this, I'm going to use placeholders within the string to format some text. So to do that, I'll type it out and I'll show you guys what I mean. So to do that, within the WriteLine method, I'm going to use a $ and double quotes. And I'm going to say, my name is, and then I'm going to use the curly braces within here. And I'm going to give it that name value and a period, and then close that off. So what I just defined is a formatted string, and I'm basically inserting the value of name within the string literal of my name is whatever. So let's see if this is working now. I'm going to go ahead and run this. And as you can see, it says my name is Ron. So this is another way to output string data. You can actually use this placeholder method or this placeholder approach to outputting variable values within a string literal. So I hope that makes sense to you. All right, so we've tackled characters and strings. Let's move on to something a little bit different here. Another data type is, what if in our application we want to be able to say whether something is true or false? Well, to do that, we can define a Boolean. So to use a Boolean, there is a reserved keyword called bool in .NET. And let's say, for example, we want to, let's say, define whether someone is a student of a school or not. So I'm going to say bool is student, and I'm going to set that to true. Okay? So this is basically saying that this particular user is a student, for example. This console.writeLine, and let's see what happens when I output is student. So if I run this, as you can see below, it outputs true because I defined true, or I set that as the value of is student. Now do notice how this value down here has a capital T as true. Now keep that in mind, that if you're outputting Booleans like this, is going to capitalize the very first letter. So if it were false, it would be false with a capital F instead. So just keep that in mind in the case if you're trying to convert a Boolean to string and you're trying to, check for a particular value, you'll have to take into consideration the casing as well. All right, so hopefully that all makes sense to you. I'm going to work a little bit harder in showing you here exactly what variables can do and the true power of variables. So let's say, for example, we want to just define or declare a variable without assigning a value up front. We can absolutely do that like this. So let's say we want to define the quantity of products in inventory. So we can actually just say int quantity, and we don't have to assign a value up front. We can just define that somewhere in the file. And let's just say we want to define a product. So we could say string data type and product. Obviously, we're saying string because the product will have a name, and the name is of a string data type. Now, in order to assign values to these variables, right below it or somewhere further down in the application within the same method call, or rather within the scope of the method, we can actually set the value. So let's say set quantity is equal to 5, for example, and let's set product is equal to bananas. Hopefully I spelled that. Something happened here. Let's try that again. Bananas. Great. All right, so now let's output that. So let's try that. Console.write line. And by the way, if you guys haven't noticed, there is a write method also to the console. Basically, the difference between write and write line is that write will output the data or the information to the console without a new line break between lines, whereas write line actually adds or skips to the new line. And I'm using write line to make things a lot easier to read in the console. So let's see here. What we want to do is let's just output here the way that we did above with the $sign and the double quotes. Let's output the quantity of the product. So let's say product as a string. And in here, we're going to use curly braces and we're going to say product. And then we're going to do a comma and say quantity. And then curly braces again, and quantity. All right, and let's run that. And as you see below, we're outputting product bananas and quantity is 5. So that's working as well. So that's basically how we can concatenate values to a string literal, as well as, you know, just declare a variable and assign the values later on. Pretty simple stuff. There is another data type that's commonly used in the .NET world, and it's called constants. So let's go down here and define what a constant is. Let's say, for example, we have a value within the application that will never change. We never expect it to change, and we want it to be read-only anyway. So for a common example, let's say that we're using a mathematical equation and we want to define pi. So we would specify the const keyword. And then if you guys remember back from math class, you have the concept of pi. What happened there? You have the concept of pi, P-I. It's not letting me do it. Let's just do it like this. Pi. And pi, we're going to set that to 3.14. Now, obviously, it's a lot longer than that, but you know, we'll just make it nice and simple. I'm just going to change this back to a capital P. I'm not sure why my autocomplete was acting up there, but we're going to set that to 3.14. Now, the reason why I'm using const here is, let's say I don't want this value to change. So I don't want someone to do something like this. I don't want them, here we go again. I don't want someone to then come and say, well, pi should really be equal to 2. So if they try to do that, you see we're getting an error message here. And basically it's saying that this is not allowed to be changed because it's a read-only value. So we generally would use this const data type to do that, to protect the value and make sure that no user is allowed to change it. So let's just output this just to make sure that we've assigned this properly. We're going to just say console.writeLine, and we're just going to output pi. And hopefully that works. I'm not sure what I'm getting an error message for. Let's see. Identifier expects. Okay, identifier expected. I'm so silly. One thing I forgot to specify here is the type. So we still have to specify a type here. We have const double in this case because it's a floating point number. And guys, again, just kind of going back to what I said, this is the reason why, you know, me personally, making mistakes makes me better. And hopefully it's going to make you guys better because you guys hopefully were able to catch that. But, you know, we define const as sort of a final value. One that will not change, and we still have to specify the data type. So const is sort of like a special data type on top of a data type, if you will. So now it looks like the error messages are gone. If I were to rerun this, now you see we see 3.14 in the console, and basically we were not allowed to change the value. So that's generally how that works. And yeah, that's pretty much variables and data types, and we're going to get a lot deeper into this as we go along.